Hi Stats class, this is another question from your 8.2 homework set. So, a couple of ways you can do this one. You can't do it directly with a TI 83 or 84, but if you just watch this example and just continue down, you get the formula for the test statistic. This is the formula that you need right here. So there's two things again you can do. You can just find the different values and plug them in here. So the sample variance is this, right? So the sample of 35 had a mean of this and a standard deviation of this. That's S, right? So S squared equals this number squared, right? And then the claimed population variance, right? That's the standard deviation right here. But that's the claim. So that value is sigma up top. So this is sigma squared is equal to that number squared. Well, I'll do it down here. This squared is equal to 3.22 squared. Alright, and then n is just number of the sample, so n equals 35, and you just go straight into this formula. So this statistic is n minus 1, it shows in the formula, so n minus 1 would be 35, minus 1, which is 34, times s squared, so times, this is what we said we're going to get for s squared, this is s. S means sample standard deviation, so we square that to get s squared, and then divided by the population standard deviation, or the claimed value. So divide by 3.22 squared. Alright, and there is our number, 37.68 roughly. So this is around the 3 places, so 37.685. 37.685. So there's how you could do it with just the formula. Now, if you want to use Stat Scrunch, again, there's not a shortcut method for the TI, but if you want to use Stat Scrunch for this, you would have to once again remember that standard deviation is the square root of variance, and we have variance stats, not standard deviation, but variance stats. All right, we have one sample, we have a summary. The sample variance is the 3.39 squared. Oops, sorry. 3.39 squared. It's 11.4921. And then the sample size is 35. We want to do a hypothesis test for the population variance. Okay, the claim is not 1, the claim is this number. Okay, this is again the standard deviation. We got to square it to get variance. So 3.22 squared. So 10.3684 is what goes here. So 10.3684, and notice this number changes when this number changes. So all we want is a test statistic, so again it doesn't matter if we pick not equals, greater than, or less than. And then tell it to compute it, and there's that same number, 37.6848. Okay, so either one will give it to you. The Chi-Sqaure test statistic comes from that, or you can use your calculator and just use that formula that they give us right here in the view and example.